Right, when you divide using long division, the first thing that's very important is you have to know which of those two numbers is outside of the little house and which one's inside the house. So out of these two, 6.25 and the 5, which number's out? How many agree 5 is out, right? You just kind of reverse it. So if it's 6.2 divided by 5, you just kind of flip it and the 5 is outside, and that's going to put the 6.25 in. Okay. I might teach it a little differently the way you learned it in elementary school, but I always tell my students that after you have it set up properly, you want to take the decimal and bring it straight up, directly straight up, onto the roof. I say raise the rock onto the roof. That's kind of the way you remember it. Raise the rock onto the roof. It's got to go straight up, because when you do long division with decimals, as these get more complicated, which they will in Mod 3, this is just kind of an introduction, but in Mod 3, where you have to start moving decimals and all that other stuff, you've got to be really, really careful how things line up properly. And then you kind of just say to yourself, okay, well, can 5 go into 6? Yes or no? Okay, so how many times? So you put a 1 here. And 5 times 1 is? These little arrows keep popping up. I'm not sure why. Everything's parked properly, I guess. I don't know. All right, so 5, right? 6 take away 5 is?
1.
Am I done? No remainders anymore when you deal with decimals. You have to go to what's called termination, which means, does anybody know what termination is? Right, you keep dropping down numbers, as you'll see, or zeros until there is no remainder, or what we call a repeating decimal. Yeah, Nick? Yes. Okay, so I got to bring down the 2, right? Same thing. 5 goes into 12 at least 2 times. Notice, if I bring down the 2, my 2 times has to go right above that 2. Everything has to be lined up properly. 5 times 2 is? Good. Am I done?
No.
Bring down the 5. What do you think? 5 into 25, oh. What's 5 times 5? Am I done?
Yes.
I have a 0 as a remainder and nothing but invisible zeros to bring down if I were to bring them down. So I'm done. My answer is 1.25. How many of you got it right? Okay, great. Try to remember to circle also. Some of you are forgetting that in your cumes. Yeah. No, it's not. Something happened there because that's a totally different number, 1.205. I think what you did is when, I'm not actually sure what you did, but it is 1.25, not 1.205. I'd have to take a look and see what you did, but there's an extra 0 in there. If, for whatever reason, there were zeros after this 5, you were okay. You just can't have zeros in between. It's a totally different number. I'll take a look at it and see. All right, number 2. Who's in, who's out? Do you remember what I call this thing? The gazinta? The gazinta. All right, so what goes into what?
3 on the outside.
Hundredths, or 3.96. You got it. Raise the rock up to the roof. 3 goes into 3, yes or no? How many times? 3 into 9. Exactly how many times? 3 into 6. Terminates. Nothing but zeros to bring down and no remainder. 1.32. How many of you got that one right? You get that one? Okay, good. What's the dot mean? Dot means 2.
Times.
Multiplication, right? When you set it up, it kind of does matter which number is on top and which is the bottom. Who goes on top? Nick? Well, what do you mean by bigger? Because technically, if you think about it, 4 is bigger than 1.65. But I want you to make believe that the decimals are not there. If it was 165 times 4, what would you put on top? All right, whatever has the most amount of digits goes on top. Okay. 5 times 4, everybody. 0, raise the 2. 6 times 4, plus 2. Raise the 2. 4 times 1, plus 2. Am I done? What did they teach you in elementary school about what to do with that decimal? Oh.
They said it goes one. It's like 2.
Okay, you got it. That's the gist, right? If you take a look at 1.65, from the left right now, that decimal has been jumped 2 times. What about 4? Did they teach you where the invisible decimal is on a whole number?
Yes.
Where does that decimal belong, even though you don't write it in? Oh, well. Right. We don't write it in on whole numbers, but there's an invisible 4 for whole numbers. Any whole number, the decimal is always to the far right. So this decimal is not moved at all to the right, 0 times. And then you add this up. If this had been ones, which it's not, you'd have a total of 3 leaps to do. But we only have 2 leaps. So starting from the far right, we leap it twice. And you get 6.60 or 6.6 if you want. And that's our final answer. Raise your hand if you got that right. Comfortable with that, right? Because you're going to need to do this in lesson 16. Okay, lesson 16. Like in any equivalency ratio table, what's the missing value? If they give you the ratio 10 to 4 and you scale down, what do you wind up getting here? Well, 5. And just kind of keep in the back of your mind, this is cost. So it's money, $5, $10. 2 packs of Coke, Diet Coke. 2 packs is $5, 4 packs is $10. Okay. Normally we would stop here. We have the value of the ratio. And you wouldn't normally be able to scale it down anymore until now, because I kind of gave you a sneak preview yesterday. Value of the ratio is not the same as unit rate, because you could still scale it down if you divide both of this by 2. That's technically what you're doing. You're scaling it down to get a value here of 1 and something. They're just showing it to you here. Oh, what'd you get? Oh, that's okay. We're going to do 3 together, but then you can just kind of check your work and see how you did. Can you do the missing value here? Right, you got 2.5, which as money, it's $2.50. Very good. How many of you also got 2.5? Okay, great. From what I hear from the kids at the high school that I've had in class now, that are up in the high school, they come back and they tell me the biggest thing that they learned that they use the most, believe it or not, in all of their high school math classes, 7th grade all the way to 12th, the biggest thing that they've learned and that they use constantly is unit rate. They use it for everything. So they even say to me now, as 16, 17-year-old kids, Mr. Alessi, stress to them unit rate, because unit rate is everything. You'll use it to solve word problems. You'll use it to find missing ratios. You'll use it to build new ratios. If you can get to this value of 1, even if it means winding up with a decimal here, that is your ticket. That is your secret. That is your golden key to unlock everything in ratio tables and word problems. Get to the unit rate. Yeah. Not for the value of 1. If you get to this 1, if I force this 2 into 1, I've divided my 2 by 2. If I do the same thing to my top ratio quantity, which I need to do, you get 2.5. In some ratio tables, will you get as low as 0.5? Absolutely. Not here. Okay. If I wanted to illustrate it further using a tape diagram, because you can do it this way, technically I took the value of 10 and I divided it equally into how many boxes? 4. Okay? Now you can kind of do mental math and realize, 2.5 for each. I'll fill it in here since we kind of know, but we can also work backwards. And if you use the Gazinta method, it's technically 4 into 10. 4 into 10 goes You say it out loud. It's fine. No, we know it's 2.5 because you know it's 2.5. If you have to go through long division, though, at least twice. Am I done?
No.
No, so now there's no decimal here, but there's an invisible decimal here, and I got to put it in now. I got to raise the rock, and there are invisible zeros after the whole number. I got to bring it down. 4 into 20. Out loud? 5. Does it terminate?
Yes.
Yep, it's termination. Nothing but zeros as a remainder and zeros to bring down 2.5. Okay. The ratios, if you go back to the first page again, the ratios that they originally gave me was that 5 to 2 and 10 to 4. All I'm going to do is just put it back in again. That's the ratios they originally gave you. The ones in between they didn't give you, we figured it out by using unit rate. So for 1 was what again? Sebastian, for 1, how much was it? Flip back if you need to. Yeah, 2.5. What goes here? 3 packs cost me how much?
2.
No. Nicole. Right, you are adding 2.5 with every leap. Or kind of think about what you did too. We've done it. Don't let the horizontal origin kind of throw you off. It's still constant. Multiplying by how much from here to here? Multiplying by how much? Times 2. Remember we did rainbows? It's still the same thing. 2.5 times 2 is 5. Rainbows. 1 times what makes 3? Right, times 3. 2.5 times 3 is 7.5. Times 4 is just a horizontal rainbow. Same idea. Okay. Let me get this out of the way. Okay, so I'm going to do a little game with you. I want you to read this quietly to yourself, the word problem. Just the word problem, the bold-faced stuff, I guess. And then I'm going to ask you to close your eyes after you're done reading it, and then I'll tell you what to do next, but I don't want to give anything away. So take about a minute and a half to read the word problem, kind of get a feel for it in your head. You got to have it in your head in order for you to know what's what, okay, to play the game. And then I'll hit the recording back again, and I'll tell you what to do. So take a minute and a half and do that. All right, close your eyes. Don't open them up until I tell you to. How many fingers do I have holding up?
2.
You said 2, you cheated. Keep them closed. Keep them closed, otherwise you're out. Keep them closed. All right, you can open them. So what I did is I underlined 1, 2, 3, 4, 5, I can't count, 6, 7 things. Out of those 7 things that I underlined, though, some of it, 8, is it 8? 1, 2, 3, 4, 5, 6, yeah, 8 things. Out of those 8 things, though, there are things there that are not important. If I call you up, you have to erase the things that are not important for solving the word problem. If you can get all the erasures, you get something. Is there anybody that I haven't called up like in a long time? Yesterday I called a bunch of people, right? I'm going Jen. All right, Jen, you got to come up and erase the VIPs that are not really VIPs, things I really don't need to solve this. That's a good job. That's what I would have done. How many of you had in that same idea in your mind if I had called you up and you done the same thing? That's a good job. Go get something top drawer. What we have left is a unit rate for one donut, and then a ratio in which we have to find unit rate. Okay? So if I buy one donut, how much is it going to cost me? How much is it going to cost me for one donut? Okay, now here's my next question. 50 cents is what number? I was going to say what rational number, but I don't want you to get hung up on the word rational. If I just say what number is 50 cents, how do you express 50 cents as an actual number? Say it. 0.50. It's actually less than $1, less than 1. So let's not forget that. It's 0.5 or 0.50. I'm just going to put this here because we are going to need it. Everything else are what we call rational numbers. They're fine. Okay? They're numbers that we're going to use in creating. I'm going to show it to you as TRF first, and then you'll realize there is a shortcut. But Ella, what's your question? You are correct. If I have this whole question here, that kind of answers my question. I should probably highlight that. And I could have probably underlined the save per donut, and that's kind of important. But I didn't even include that in the little game. But you are right. Eventually, when we solve this, we got to go back and answer the question, as you'll say. Fair point. Okay, we're going to set it up as a TRF. Very important to understand the concept, and then maybe you'll see the shortcut without me having to tell you what the shortcut is. Template ratio find. Okay. What's the template? What things are being compared in the ratio? Madison? You got it. Donuts and money. I'm going to list it in the order in which it's presented. So they talk about the money first and then the donuts. Watch how I can label money. I can put a little dollar sign for money. Do that. You're going to need to do that in a couple of weeks, 3 weeks anyway, when we do tax tips and discounts. Yes? I don't have an eraser head, but I've got this. That'll help you out. Okay. And then donuts, we'll do D, representing D for donuts. Okay, great. For now, I don't need this. Because I already know from this piece that one donut is 50 cents. I'm going to save that for later, because I know the unit rate if I don't take advantage of the sale. I need to find out what the cost is for one donut with the sale. So I'm going to take this ratio, and I'm going to place it into the first part of my ratio, of my template ratio find. 5 and $2, which is really 2. Which of the numbers goes on top? A 5 or the 2? Nearly worm. 5 and 2, what goes on top?
No, the money.
Right, money, which is $2, because I established that in my template. This becomes the hard part. It's hard, because you haven't seen it, but it's actually easy. I'm trying to find the cost for how many donuts. Trying to find the cost for how many donuts. Matthew, one donut. So 1, where does it go? Top or bottom? Brian, bottom. And I'm trying to find the cost for that. I have everything that I need for 4 corners now, right? I got to figure out what's being done between the 5 and the 1. First of all, multiplying or dividing when numbers get smaller. Nick? Okay, dividing by, but not by 1. Because 5 divided by 1 is not 1. 5 divided by 1 is 5. 5 divided by 0 is 0. It's alright, you'll get it. Watch, work backwards. 1 times what makes 5? So then 5 divided by, divide by 5. Any number divided by itself, you'll wind up with 1. You can do it backwards. You can do it backwards. I'm just showing you Now I got to do 2 divided by 5, don't I? Well, guess what? You're right back to what you did in the warm-up. Who's in, who's out? Ryan.
The number that's in, that is in the 2.
Yes.
Dividing it and dividing it, so it would be 50 cents.
You're close. Not quite. Yeah, but let's go through the long division just so you can see it. Well, let's do it. 5 into 2. Can it work? Does 5 go into 2? No, right? Agree? No. So we now automatically know it's going to be a cost under $1. But I'm not done. You can't just say, oh, 0 remainder of 2. You can't do that anymore. You've got to put a 0 here. Now I've got to deal with that decimal and invisible zeros. Well, let me add the 2 zeros back in again since we originally had it. Raise the rock. 5 into 20. 4. Does it terminate? It does. 0.4 is what as money? Well, 40 cents. Is everybody okay with that, how I got 40 cents? Now I need to go back and say, all right, well, it's 40 cents per donut if I take advantage of the sale. If I don't, what's it costing me per donut? So now I need the first part of that word problem. Shane, 50 cents. So now let's go and take a look at what they're asking me. How much is the customer saving per donut by taking advantage of the sale? Alexa, everybody agree, 10 cents. Got it. You can show it. You can show me 10 cents 2 ways. You can do it this way, a lot of writing, or you can use a little cent sign. I'm okay with that. That's fine. Yeah. Yeah, but they put the cents after. The cent sign goes after. The dollar sign, if you show 0.10, the dollar sign for any dollar value goes before. The little cent sign goes after. Okay, they take it a step further. Let's look at C. How much would it cost the customer to purchase 5 donuts, no sale? Got to kind of work backwards because they kind of tell you what the cost is per donut. I'll tell you what, if I call on you, just tell me. You got to tell me how you got it. Tell me how you can tell me the answer, but you got to tell me how you got it. Ava, what do you got? How many say $2.50? Okay, how'd you do it? Okay, you can count by 55 times. It's fine. Or if you use straight multiplication, what times what? 50 times 5. It's actually 0.5. 0.50 times 5. If you do it this way, you'll wind up with the same thing. Just got to remember, be careful where you put your decimal place. Because look, you got to leap it 2 times. If you leap it twice, you get $2.50. Finally, the home run question. Tying everything together. How much do they save in total? 5 donuts. And again, if I call on you, just tell me how you did it. Nate. Yeah, how'd you do it? And there's different ways to do it. There's 2 ways you can do it. How did you do it?
Well, there's 5 donuts in place.
Run it by me again. I start over from the beginning. How'd you do it? There's 2 ways you can do it. One using straight multiplication and one using subtraction. But go ahead. Go ahead. I'm listening.
Okay.
So is the rest of the world. But go ahead.
Okay. So there's each donut when you save money is for 40 cents. So you're saving 10 per donut, and there's 5 donuts. So 10 cents times 5 would be 50 cents.
So run it by me one more time.
Okay. One more time. Okay, so how would it would, so each cent, when you save it, it's each 40 cents per donut.
40%, 40 cents per donut
And
sale price. Okay, gotcha.
so there's 5 donuts.
Okay,
So if you multiply 10 times 5, because you're saving 10 cents, times the 5 donuts will get you 50 cents.
gotcha. Okay. So what you did was you took this 10 cents, multiplied that by 5 donuts, I think, right? And you got 50 cents. Okay. What's the way to do it using subtraction, though? You could do it 2 ways. All right. Well, here, yeah. Let me get the microphone here. All right. What'd you do?
So since that says the sale is 5 donuts for $2,
Yep.
and this one is at 5 donuts with no sales, $2.50,
Yep.
and you're saving $10 on each donut. 50 divided by 50. Yeah, 50 divided by 10. Wait, no, I did it so easy. It's like you just like pretty much just take the 50. What I did is just took this away. Well, it's hard to. Well, I had it in my
Well,
head and I just lost
listen, again,
So-
there's a lot of different ways to do it. I understand.
I
But
got it again.
here's your hint. How do you do it using subtraction? What 2 numbers would you need to subtract? Good.
So for this 250.
All right, gotcha. Start with that.
250 divided by $2 equals 50 cents.
Not divided by $2.
No,
250.
Minus 250 minus
50 minus.
$2.
Yeah, 250. Right, you got it. $2.50 was the non-sale price. $2 is the sale price. Again, for 5 donuts, subtract and you get 50 cents. And there's other ways to do it too. You have a look of confusion on your face. Yeah. You good? All right. So here's the deal. I'm actually that's gonna conclude my portion of the lesson. But let me tell you what you guys are gonna do. First of all, I'm gonna keep it running. Do you know what the shortcut is? Without needing to show TRF.
Yes.
Give you a little hint. If you look at the top of the page, I kind of tell you. And again, if the shortcut confuses you, then do TRF. Shortcut takes you it drops out a whole entire step. Ryan Wetter, do you know it? I know he knows it.
Yeah.
What do you do?
You do thing that's at the top of the page.
Which is what? Explain to the class.
We'll to pretty much like kind of like counting up, like it, the top at the top that was going up by like 2.5 and 2.5 at the top.
I was talking about this though.
Oh.
If you look at the top of this page, if you wanted to, and only if it doesn't confuse you, it's really the cost divided by the things that you're buying. In this case, donuts. Right. If you take the cost, any one of these costs, doesn't matter. We could do, oh, it's the donuts. The cost was $2, right? You take the cost, which is 2, divided by whatever things that you're buying. In this case, is donuts. It's 2 divided by 5, which we got to. It'll always work out that way if you do the cost divided by the items. You just have to remember that if you write it out this way, when you solve it using the Gazinta method, you've got to reverse it. The 5 goes out and the 2's got to go in. Because if you do reverse it, remember the order does matter in division. If you reverse it, you're going to go down the wrong path and you're not going to wind up with the right answer. And if this confuses you, then show it as a TRF and you'll get it. Okay? All right, so let me pause this. Yeah. Again? Okay, you want to... Oh, all right.